Welcome to qnawire.
So here we're simply going to follow the hint. We know that the mass of the cutout piece is proportional by area to the mass of the entire piece. So we can say that the total moment of inertia would be equal to 1/2 times mr sub o squared. This would equal the moment of inertia of the remainder or the remaining piece plus the moment of inertia of the cutout. Therefore, the remaining moment of inertia would be equal to 1/2 mr sub o squared minus the moment of inertia of the cutout. We can say that the moment of inertia of the cutout would be equal to 1/2 times the mass of the cutout times the radius sub 1 squared, we'll just call it sub 1, plus the mass of the cutout times h squared. And we can say that then the mass of the cutout would be equal to the total mass divided by the area that was cut out multiplied by, or rather, the area of the total, the total area rather multiplied by the area that was cut out, pi times r sub 1 squared. This is equaling m r sub 1 squared divided by the total area r sub o squared. So we can say that then the moment of inertia of the remainder would be equal to 1/2 times mr o squared minus 1/2 times the mass of the cutout times r sub 1 squared plus the mass of the cutout times mass of the cutout times h squared. My apologies. And then we can say that the moment of inertia of the remainder would then be equal to 1/2 times mr sub o squared minus m r sub 1 squared divided by r initial squared times 1/2 r sub 1 squared plus h squared. And we can say that the moment of inertia of the remainder will then be equal to 1/2 times m over the initial radius squared times the initial radius to the 4th power minus the radius of the cutout to the 4th power minus 2 times r sub 1 squared h squared. This would be our final answer. That is the end of the solution. Thank you for watching.